The thrust management function of the flight management computers uses environmental and performance data to calculate engine thrust reference limits. These limits provide engine thrust reference values for specific flight phases. Thrust reference limit modes and TPR values are displayed on and above the ICAS TPR gauge. Available thrust reference modes include takeoff, climb, continuous for non-normal conditions, cruise, and go-around. When VNAV is active, thrust reference limits sequence automatically when changing phase of flight. Thrust settings can also be selected manually via the thrust limit page on the CDUs. The normal takeoff thrust reference commands engine TPR to 100% rated takeoff thrust. However, takeoff thrust can be reduced to lower operating EGT and extend engine life. Two methods may be used to limit takeoff thrust: derate and assumed temperature. Takeoff limit thrust reductions are selected on the thrust limit CDU page. If takeoff 1 or takeoff 2 is selected, the maximum rated engine thrust will be decreased by 10% or 20% respectively. The select prompt moves to the selected derate. The ICAS thrust reference mode changes to takeoff 1 or 2, and the reference and target TPR indications decrease. Derate thrust setting parameters are considered a limitation. Thrust levers should only be advanced past the limit TPR value in an emergency situation. Assumed temperatures are entered in the Select OAT field on the thrust limit page. Entering an assumed temperature that is higher than the actual temperature will reduce the reference takeoff thrust limit. The maximum authorized thrust reduction is 25% below the certified rating. When an assumed temperature is entered, the thrust limit mode displays DTO. Assumed temperature is not a limiting thrust factor. If conditions are encountered during takeoff where additional thrust is required, the crew may manually apply full thrust. Two derated climb thrust limit options are available from takeoff to 30,000 feet. Climb 1 reduces normal climb thrust by 5%, and Climb 2 reduces normal climb thrust by 15%. Derated climb thrust can be selected manually on the thrust limit page or automatically based on the combined takeoff thrust reduction using derate and assumed temperature. If the total takeoff derate percentage is less than 5%, normal climb is selected. Between 5% and less than 15%, Climb 1 is selected, and 15% or more, Climb 2 is selected. Each engine has two igniters. The EEC automatically selects the appropriate igniter for successive engine ground starts. Dual igniters are always used for in-flight starts. Ignition is controlled through the fuel control switches. Aircraft-supplied DC power is the normal power source for ignition. Standby power provides a backup power source for energizing the igniters. The electrical system powers two starter motors mechanically connected to the N2 shaft via the accessory gearbox. The starter motors are controlled via the start selectors. During engine starts, power to run the starters is drawn from the airplane's electrical system. There are two normal power sources that can provide starter power: the APU and forward external power. Normally, APU power is used to drive the engine starters. Simultaneous engine start is only allowed when the APU is running and both APU starter generators are operational. If both engines are commanded to start with an inadequate power configuration, the second start command is ignored. In the event both starters on the respective engine fail, starters will display across the respective starter symbols on the electrical synoptic, and the ICAS displays the advisory message engine starters left or right. Auto start operation automatically sequences fuel and ignition during start, with no input from the pilot. The engines can only be started using the auto start system. The auto start sequence is initiated by rotating the start selector to start and moving the fuel control switch to run. For in-flight windmill starts, the auto start sequence is initiated by moving the fuel control switch to run. The start selector applies electrical power to the starter motors to begin dry motoring the engine. Additionally, the spar fuel valve opens when the start selector is moved to start. The spar fuel valve will also open if the fuel control switch is moved to run. Positioning the fuel control switch to run will command the EEC to open the engine fuel valve, and energize the igniters at the appropriate N3 RPM. While the EEC is in auto start mode, auto start is displayed in white above the N2 indication. The auto start indication blanks when the system is no longer attempting an engine start. When the engine reaches idle speed, the EEC will command starter cutout. The start selector releases to the normal position, and running is displayed in green above the N2 indication for 30 seconds. During ground starts, the auto start system monitors engine parameters for any of the following conditions: loss of both starters and no N1 rotation. If one of the above conditions is detected, the EEC aborts the auto start sequence without motoring and does not make another attempt. The starters are de-energized and the start selector returns to the normal position. And the ICAS displays the caution message, engine auto start left or right. The auto start system monitors engine parameters and attempts to correct the start for any of the following: compressor stall, hot start, hung start, loss of one starter, no EGT rise, and start time exceeding the starter duty cycle timer. If any of these conditions are detected, the EEC will automatically turn off fuel and ignition, motor the engine for 20 to 30 seconds, then make a second start attempt. This second attempt uses a reduced fuel flow and turns on both igniters. If the second start fails, auto start mode is canceled by the EEC and fuel and ignition are shut off, engine is motored to clear residual fuel, starters are de-energized, start selectors return to normal, and the engine auto start left or right caution message displays. There is a limit of 2 start attempts on the ground. In-flight start envelope information will display on the ICAS when an engine is not running in flight, N2 RPM is below idle RPM, or an engine is shut down in flight and the respective engine fire switch is not pulled. The in-flight start envelope indicates the airspeed range necessary to ensure an in-flight start at the current flight level. If the current flight level is above the maximum start altitude, the maximum start altitude and respective airspeed range are displayed. If airspeed is below the speed recommended for a windmilling start, a starter assist indication is displayed below the N2 indication. Secondary engine indications are also automatically displayed in flight when an engine is not running, N2 RPM is below idle with the corresponding fuel control switch in run, or a fuel control switch is moved to cutoff. For in-flight starts, AutoStart will continue making successive start attempts until the engine starts, or the pilot aborts the attempt by moving the fuel control switch to cutoff and the start switch to normal if necessary. The EEC monitors engine parameters during a windmilling start to provide the best fuel schedule to ensure the shortest possible start time. Engine auto relight protection is provided for flameout and sub-idle stall recovery. The auto relight function is activated whenever a flameout is detected, or the engine is at or below idle with the fuel control switch in run. When activated, the EEC energizes both igniters for the respective engine in an attempt to recover the engine. This also provides protection against flameout during periods of excessive rain or hail ingestion. The igniters are switched off when the engine reaches idle. Fuel is supplied to the engines by pumps located in the fuel tanks. Initially, the fuel flows through a spar valve located in the main tank. It then passes through the first stage engine fuel pump where additional pressure is added. Next, the fuel is preheated by a fuel oil heat exchanger. After the heat exchanger is a fuel filter that removes any contaminants. The fuel then passes through the second stage engine fuel pump where additional pressure is added. The fuel metering unit, or FMU, adjusts fuel flow to meet thrust requirements. Finally, the fuel flows through a second high-pressure filter before passing through the engine fuel valve and into the engine. The spar and engine fuel valves allow fuel flow to the engine when both valves are open. The spar valve opens when the engine fire switch is in, and either the start selector is in start or the fuel control switch is in run. The engine fuel valve opens when the engine fire switch is in and the fuel control switch is in run. Both valves close when the engine fire switch is out or the fuel control switch is in cutoff and the start selector is in norm. Fuel flow is measured after passing through the engine fuel valve. Fuel flow information is depicted on the secondary engine display and sent to the FMS. The oil system provides pressurized oil to lubricate and cool the engine main bearings, gearbox, and accessory drives. The oil system also provides automatic fuel heating for fuel system icing protection. Oil is pressurized by an engine-driven oil pump. From the pump, the oil flows through the oil filter. Next, the engine oil is cooled by a fuel oil heat exchanger. A secondary air-oil heat exchanger provides oil cooling under conditions of low fuel flow or high fuel temperatures. After cooling, oil is delivered to the various components. Finally, a scavenge pump returns the oil to the reservoir. A scavenge oil filter is installed just prior to the oil returning to the reservoir. If the filter becomes clogged, the ICAS advisory message "Engine oil filter left or right" is displayed. A bypass allows the oil to continue past a clogged filter. Oil pressure, temperature, and quantity are displayed on the engine display. Oil pressure is measured prior to entering the engine by dual oil pressure transmitters. If pressure decreases below the operating limit, The ICAS caution message, engine oil pressure, left or right, is displayed. Oil temperature is measured prior to entering the engine by dual oil temperature transmitters. If oil temperature reaches the red line limit, the ICAS advisory message, engine oil temperature, left or right, is displayed. Since oil quantity is displayed only as a value, there is no amber or red line limit. However, a low oil quantity will cause the secondary engine indications to display and the indication to show black numbers on a white background. There are also no operating limitations for the engine oil quantity. As a result, there are no flight crew procedures based solely on a response to low oil quantity. Each engine has a hydraulically actuated fan air thrust reverser. The thrust reversers are operated through the EECs and the reverser isolation valves. The EEC inhibits reverser isolation valve actuation and reverser deployment unless the airplane is on the ground with the engine running. The EECs also control thrust limits during reverser operation. The thrust reversers are controlled with the reverse thrust levers located on the throttle quadrant. The reverse thrust levers can be raised only when the forward thrust levers are in the idle position. When the reverse thrust levers are raised, the EEC opens the reverser isolation valve. A physical interlock located in the aisle stand provides tactile feedback to the pilot, informing when the thrust reverser is or is not deployed. The interlock prevents movement of the reverse thrust lever beyond the reverse idle position until the cowl is partially deployed. When the reverse thrust levers are pulled aft to the interlock position, the auto throttle disengages and the auto speed brakes deploy. When the reverser system is activated, the reverser translating sleeves hydraulically move aft. Reverse is displayed in amber when the reverser is in transit. The fan flow blocker doors rotate into place to direct fan air through stationary cascade guide vanes. And reverse changes to green when the reverser is fully deployed. Pushing the reverse thrust levers to the full down position retracts the reversers to the stowed and locked position. The thrust levers cannot be moved forward until the reverse thrust levers are fully down. The ICAS advisory message, engine reverse limited left or right, is displayed if the reverser cannot deploy when commanded or can deploy only with reverse thrust limited to idle. The ICAS advisory message, engine reverser left or right, is displayed on the ground to indicate a reverser system fault. The caution message, engine reverse air ground, is displayed when the air-ground logic that prevents in-flight thrust reverser deployment has failed. The caution message, engine reverse commanded left or right, is displayed when the left or right reverse thrust lever is not in the down position in flight. The engine monitor unit tracks engine vibration levels. The vibration indications are displayed on the secondary engine display. The vibration source indication, N1, N2, or N3, is also displayed. If the vibration monitoring system cannot determine the source, BB, or broadband, is displayed for the affected engine. Broadband vibration is the average vibration detected. The airborne vibration monitoring feature is intended to track rotor imbalance. There is no certified vibration limit, but when a vibration value of 4 units is reached, the secondary engine parameters are automatically displayed, and the digital vibration readout is displayed in reverse, black digits on a white background. Since there are no operating limits, there are no specific flight crew actions based solely on vibration indication. The engine failure alert system provides alerts when actual engine performance is less than commanded engine performance. Engine fail is displayed on both PFDs and HUDs if actual thrust is less than commanded thrust during takeoff, with airspeed between 65 knots and 6 knots prior to V1. In addition to the engine fail display, the engine fail aural sounds,
engine fail,
and the master warning lights illuminate. The ICAS caution message, engine fail left or right, is displayed if an engine unexpectedly decelerates to less than idle speed. The message remains displayed until the engine recovers or the fuel control switch is moved to cutoff. The ICAS caution message, engine thrust left or right, is displayed if airspeed is greater than 6 knots prior to V1 and the engine is producing less than commanded thrust and actual thrust is not satisfactorily increasing toward the commanded thrust, or the engine is producing more than commanded thrust and actual thrust is not satisfactorily decreasing toward the commanded thrust. In addition to the engine thrust caution message, the thrust command arc is filled amber, the master caution light illuminates, and an aural beeper sounds.